Hello, everybody. Thanks for joining in, everyone. So we will have also people, I guess, joining in while we're speaking at this event. Okay, as you see now. So this is our 6th event of our AWS community in Kosovo from the AWS user group Kosovo. We had the first one we had at Ditanat, the cafe, with Visar as our speaker. Then we had another one at Innovation Center Kosovo, where it sort of became a tradition to have the reInvent recap. 2019 was the first one, 2020. So it's a tradition of 2 events, but still, we look to make it a tradition. And Darko Mesaros from AWS came to speak with us at the first one. So, but the second one, due to the pandemic, it was this year, actually. The first event is this year. It was online, as this one is. So today we're going to talk about DynamoDB. Why has it been the database of choice for serverless developers in the AWS ecosystem? We will have the chance actually also to ask Alex, who's an AWS data hero, a DynamoDB fan, serverless evangelist with broad-based experience. So you can follow Alex actually at his blog. Check out his blog, alexdebris.com. And he's quite active there, actually, with articles about everything you need to know about DynamoDB partitions, the limits, the API gateways, and etc., and so on and so on. So you actually have a lot of posts, actually, like 4 blog posts only in 2021. So, and there are also other ones from last year and the year before. But I guess none of you have come here to hear me speak. So we're going to just get on with it now. Alex is going to speak, and you can ask, we discussed before with him, you can ask questions if you want while he talks, but also while he presents, but also he will present in sections, and you can also talk, ask questions either in written or like using the mic. You can ask questions in between segments when he opens for questions, but we will let that to Alex to decide how he wants to interact with you guys. We also have 5 copies of his book to give away. Alex would show us. No. You have the book there? I thought you wanted to reach out for the book to show us the book. Okay, it's an online book.
Anyway, I was getting my phone out here just in case during the talk. I'll get it out of here. So.
Cool. So yeah, you can tell us something about the book and then just start.
Cool. Sounds good.
Thank you for coming.
Absolutely. Thanks for having me. Yeah, I got a little pitch for the book later on, but yeah, I'll just hop right in. Again, feel free to ask questions. However, you can drop in the chat. You can just sort of pipe up. I'll try and stop at the end of every section and look for questions, but sometimes I miss them. Sometimes, so, and we'll also have Q&A at the end. So, but anyway, I'm gonna get started. Hope y'all can see my slides. I'm gonna be moving through some slides, so if you don't see anything changing, please let me know because I do have slides going on. So, but yeah, if you've been doing software development in the last couple of years, you've probably heard about serverless application development, serverless compute, things like that. And serverless means a lot of things, but really, I think the thing that really started this and kicked it off was the introduction of AWS Lambda at reInvent 2014, where you have this event-driven functional compute where you upload a zip file of your code and it's going to run when a particular thing happens. It was this auto-scaling pay-per-use compute, really big change, but Lambda by itself is not enough. It's event-driven compute, so usually you have some sort of event that triggers it, and that might be something like API gateway, right? If you want to hook up an HTTP endpoint to your Lambda function, you can do that with API gateway, and that works great. And then, but even API gateway and Lambda is usually not enough, because usually you need to store some state somewhere or interact with that data in some ways. So you might store some data in S3 or read some data out of S3 with that Lambda, or you might enqueue a message in something like SQS, or you could use any of these sort of fan-out services like EventBridge or Kinesis or SNS. But most commonly, you're probably going to be using some sort of database in your application somewhere, and even there you have a lot of different options you have, right? You have Amazon RDS, which has relational SQL-based databases if you like that. You have DocumentDB, which has, if you want like a Mongo-like experience there, you can use that. Or you can use DynamoDB, and that's what we're going to talk about here today. And I think Dynamo has been a pretty popular choice among serverless developers for reasons we'll get into. So this talk is all about using DynamoDB in serverless applications. And I want to talk about 3 different things here. Number one, we'll start off with why DynamoDB in serverless. Why are so many people choosing to use DynamoDB over different options, especially in serverless applications, where I think we're seeing a lot of growth and energy around Dynamo. And then we'll get into more specifics about data modeling with DynamoDB. So we'll talk about the basics of data modeling with DynamoDB, do some vocabulary, terminology, and some key concepts there. That can be sort of conceptual and hard to visualize. So then we'll bring it back down with some practical stuff by talking about how to model one-to-many relationships and hopefully compare it to what you're seeing in a relational database if you're new to Dynamo. Who am I? I'm Alex Three. I wrote the DynamoDB book. Created DynamoDBguide.com. I'm an AWS data hero. I'm just, big AWS fan in general. We mentioned the book earlier, so it's the most comprehensive guide to data modeling with DynamoDB out there. It's very long, so it's 450 pages and has a bunch of extras. It has like 5 walkthrough examples, so we model like all of GitHub in there, right? If you're familiar with GitHub, we do show how to do like users and organizations and repos and issues and pull requests and comments, all that stuff, very detailed stuff. So if you want to do that, go ahead and check that out. It's at dynamodbbook.com. You can get a free preview there. And with that, let's get started. So first segment is going to be about why DynamoDB and serverless. Again, a lot of people choosing DynamoDB with their serverless applications. Why is Dynamo the right choice for a lot of people? And how is it different than relational databases? This is not going to be about data modeling that much. This is sort of like operational aspects or things like that make Dynamo a nice fit with serverless. So 6 things I want to go through. First thing is just the interaction mechanics. If you're using serverless applications, if you're using Lambda, you're often tying together other managed services from AWS. And like I showed early on there, it could be S3, SQS, SNS, Kinesis, just all these different AWS services that are sort of hooking together. And the nice thing about DynamoDB is how similar it is to using those other services in your Lambda function. So just looking at a little bit of the code here, if you're working with something like SQS, this is what you'll have. This example's in Python, but it applies to sort of any language you want, right? You'll import the AWS SDK, whether that's Boto 3 in Python or if it's just the AWS SDK in Node or something like that. You'll import that library. You'll create a client from that library. So here I'm creating the SQS client, and then you'll just call that method on that client, client.sendMessage, and it's going to map up with the available API methods from that service, right? And this is what it looks like for SQS. If you're working with S3, it's going to be very similar, same sort of thing here. Import that library, create that client, call the method. Now, the nice thing about Dynamo is it's very similar here as well. Here's how you do it in Dynamo. Again, same thing. Import that library, create that client, call that method on it. So if you're already used to using that AWS SDK, creating those clients, calling those methods on it, it's going to map very well to using DynamoDB, as compared to using like a relational database where you might have like a connection pool, need to handle some of the mechanics around how you execute queries against a relational database is just going to be different, right? So you're already sort of going through this motion with other AWS services in your serverless applications. So that's the first one. Second one, again, just similar mechanics of how you use other services is going to be around the permissions model for DynamoDB. So, if you have serverless applications, you're probably using something like CloudFormation, or this is the serverless framework, which uses CloudFormations. But if your Lambda function is calling another AWS service, you need to set up permissions using AWS IAM. So if you're going to use SQS in your application, you'd have something like this in there where you say, hey, I want this Lambda function to be able to call the send message method, that we were using in our application I just showed on this particular queue resource. And you can see that's what how you set this up so that your Lambda function can do this. Now, if you're working with DynamoDB, same sort of thing applies, right? You need to allow Lambda to, read items from your table, put items in your table, query, delete, however you want to do that. And you're going to set it up the same way. So once you get familiar with IAM in Lambda with SQS, with S3, things like that, it's going to apply to DynamoDB as well. Another thing that's really nice about how permissions work with Lambda, right, is you associate a role with your Lambda function, you give it those permissions that we just showed, And then you're going to get temporary credentials injected into each Lambda container instance that you have. So each one of those will have temporary, time-scoped, limited credentials. And those credentials are automatically discovered by the AWS SDK. So the great thing is you don't have to really think about credentials, credential rotation, things like that, like you would with a relational database. If you had a username and password, how do you sort of rotate that every once in a while and manage that? Whereas Lambda is going to manage this for you if you're working with AWS services and IAM. So permissions model, that's the second one. Third one is going to be the provisioning model, right? How do I actually create my infrastructure here, create my database, things like that. If you're using serverless services, you're probably using CloudFormation. So, if you're provisioning an SQS queue, you might have some CloudFormation that looks like this, where you're creating this SQS queue, specifying the type, the properties, all that stuff. If you're creating a DynamoDB table, same exact thing you're going to do there. You can use CloudFormation to provision this, and the syntax will feel very familiar for you. Now, if you want to use a relational database in something like RDS, you can use CloudFormation to provision that relational database, but there are certain things where you need to sort of prepare your database outside of CloudFormation in a relational database, right? You need to create your tables, create your indexes, create users, add permissions, things like that, where you don't need to do that sort of outside of CloudFormation with DynamoDB. In Dynamo, you can create your table, your indexes, all that stuff straight in CloudFormation without having this sort of post-provisioning step or something like that. So provisioning model works very well with Dynamo there and serverless applications. I talked a little bit about infrastructure as code, and that's just where you define all the different infrastructure you want, your databases, your queues, your S3 buckets, your API gateway, things like that. You define it in code, so you have this repeatable process, reviewable process. You can use tools like CloudFormation or Terraform. In the serverless world, CloudFormation has really been a lot more popular just because of some of the tooling built on top of CloudFormation to make it easier to use to build serverless applications. So whether you're talking about the serverless framework, AWS SAM, CDK, Begin, things like that. Whereas Terraform, third-party tool from HashiCorp, I'd say it's popular in other areas of the community, but not as much in the serverless world, just because that tooling hasn't been built on top of Terraform like it has been with Lambda. And then again, the nice thing about infrastructure as code is it gives you this repeatable process for provisioning your infrastructure, things like that. So let's move into the fourth reason of why DynamoDB and serverless, and this is about the billing model. With a lot of serverless services that you're using, it's a pay-per-use business model, right? So Lambda, right, you're only paying for when your function is running, as compared to EC2 instances where you're paying for your instance to be available all the time, even if you don't have requests going on it. Same thing with API gateway, you pay per request. Same thing with S3, SQS, a lot of these things. And Dynamo is similar. So I think Dynamo is unique in two ways from sort of traditional databases. Number one is that you're paying for reads and writes directly rather than resources. So if you think about a traditional database, whether it's a relational database or even MongoDB, right, you're spinning up instances that have some amount of CPU and RAM and IOPS and network and all that sort of stuff. And what you need to do if you want a capacity plan is say, hey, I'm expecting this many users that are running this many queries. And then you sort of need to guess on how that turns into CPU, memory, IOPS, things like that. It's sort of like, how do I turn that into the actual operations themselves? Dynamo is different. It's going to actually charge you based on what are called RCUs, read capacity units, and WCUs, write capacity units. And that's basically how much actual data are you reading and writing in your request, right? So 4 kilobytes of data is a read request. 1 kilobyte of data is a write request. And it's charging for you directly. So if you have a decent sense when you're capacity planning of like, hey, I have this many users making this many queries, this is how large they are, you can actually calculate how many WCUs and RCUs you need, and you don't have to convert it to RAM and CPU and things like that. So that's pretty nice. So even just like that traditional model is really nice. The other thing that's nice about Dynamo is they actually have 2 types of billing modes. So they have provision capacity, where you can say up front, I want this many RCUs and this many WCUs available per second on my table, just ready to go. Or you can do pay-per-use mode, where you're saying, hey, I'm not going to tell you how much I need. I'm just going to issue queries against my database. You charge me for each individual query based on how big that query was, and send me a bill at the end of the day. And that's pretty nice, because now you don't really need to think about capacity planning. And also it's, pay-per-use is a little more expensive than provision capacity if you were able to like fully utilize your provision capacity. but a lot of people aren't. So, if you have fluctuations during the day or during the week or during the month, right, you often have a lot of unused capacity. Pay-per-use can actually save you a lot of money there. So it's another thing that's nice about this, right? Fits really well with that serverless billing model. All right, next thing I want to talk about is just the development environment, right? If you're doing serverless applications, you have your application declared as infrastructure as code. All your services are pay-per-use sort of auto-scaling type things. What this means is, you can have your production environment, but you can also have each of your developers can have their own full environment in their own AWS account, isolated, give them a very high fidelity copy of basically production to work against and develop against. And because all of these things that you're using are pay-per-use, they're very cheap to run copies of. And then also because it's declared as infrastructure as code, you can spin it up very quickly. So if you can have a very nice development environment that's very similar to what you're going to be working with in production without having these sort of long run or these big RDS instances running. Yeah, I see. I've got a question. Who's that? Mimose? Did you have a question?
Yeah. So you're saying that you would kind of set up DynamoDB into another account and that would be isolated. And I understand that's great, but kind of wondering, maybe you are going to say something about that right away, but I'm wondering, do you have some kind of setup that you do locally? Let's say, or maybe what's your favorite? Because there are some different ways like local stack or SAM to run this locally, so you don't have to deploy it into another AWS account, because that means cost, right?
Yep.
So yeah, just wondering about that.
Yep, good question. I mean, one thing I would say is you mentioned it means cost, but if you're doing like a testing environment, you're deploying this table into your own account, and you're using like on-demand mode. On demand is like it's gonna be like 25 cents per million read requests or something like that, and it's kind of hard for you to do a million read requests when you're testing. Because it's just like, you're not hitting it that much compared to your actual production traffic. So it usually ends up being pretty cheap to have this full copy. But I think your point is good too. Like, what can I do locally? Because a lot of people like that experience, or maybe they do test enough that it will cost something. What can I do there? My recommendation is it depends a bit on like how complicated your infrastructure is. I think if it's just API Gateway, Lambda, DynamoDB, you can replicate that locally pretty easy using local stack if you want. You can even do like there's a tool called DynamoDB local that you can just run as like a little Java app. You just fire that up and you can connect to it locally, like on localhost. It's like a very easy config change in your AWS client to connect to that. You can use that, and most of the serverless frameworks have like an HTTP API gateway emulator there, so you can do all that stuff locally if you want to. If you start adding more complex stuff into your infrastructure, like step functions or Kinesis streams, DynamoDB streams, that's where I stop emulating that locally, even with something like local stack, just because it gets harder to like really truly emulate that well. But it sort of depends on your preferences. You can, definitely try that stuff out if you want to. But yeah, things I would say there is check out DynamoDB local, which is going to be a pretty high fidelity copy of Dynamo that you can just run on your local machine, or I'd advise running in the cloud too.
Nice, thank you. I was just thinking, with serverless is great because cost is so little and there's only cost if you use it. So you can have stuff running there, like not running, but available in the account, and it will not cost anything unless you use it. But then just thinking in general, if you have things that are not serverless and you would prefer, let's say, working locally rather than having everything deployed. But anyway, yeah, thank you for the answer.
Yeah, I think that's a great point of what you're saying. Like, if you have things that aren't serverless, now it's harder to have that like high fidelity, your own AWS account copy, because it's like, okay, now if I have an RDS instance, or if I have something that does charge like per hour, per instance, it's harder for me to have that because now it actually does cost some money, where like a Dynamo table is basically free. So yeah, I think that's another reason for Dynamo and serverless here. Yeah, great question. Cool. Last thing I want to talk about is just like the scaling characteristics of Dynamo, which I think a lot of people like, because API Gateway, Lambda, SQS, all these things are sort of auto scaling infinitely, and Dynamo has some pretty interesting scaling characteristics that you don't see in a relational database. So what I want to do here is just sort of compare sort of the general scaling behaviors of some different databases. And what I have here is just a chart. On the x-axis, I have your data size, right? How much data do you actually have in your database instance. And it starts at 1 gig, then 10 gigs, 100 gigs, terabyte, things like that. And then on the y-axis, I have performance. And it basically, you can think of this sort of as like response time or latency. So higher is worse, right? Blazing fast is at the bottom, then fast, then sluggish, then painful. And this isn't actually like to scale or a perfect, mathematical chart or anything like this, but I'm just trying to show the principles, the concepts here. And if you have a database like MySQL, some sort of relational database, or even MongoDB, you might see a performance curve sort of like this that gets slower over time, right? So when you're running it locally, you're running it in your staging environment, or you just deployed to production, you don't have a lot of users, you can be like, hey, this is really fast. Everything fits in memory. I'm indexed well. This works really well. You get down the road, you get more users. It's sort of been out there for a while, and it starts to feel sluggish. You're getting complaints from users about how long this takes, and someone needs to go investigate, right? And maybe they need to add another index or denormalize in some way, or handle it in some particular way, increase the instance size, but you need to investigate. And then you might get to some point where it's just so sluggish, so unbearable or untenable that you need to actually re-architect and change what you have. So what you have here is like this long-term drag on your development agility, where you need to like keep maintaining the speed of your database as that data grows. In contrast, DynamoDB's performance curve is going to be something like this. So it's going to be totally flat. And two things I want to call out here, to be fair, like number one, on the far left side of the curve, like if you have a small amount of data, something like MySQL, Postgres can be faster than DynamoDB, right? You have this persistent connection, everything's in memory. It can be very quick with a relational database and a little slower with Dynamo, although Dynamo's gonna be fast enough for almost all circumstances. But the second thing, and the more important thing, is just like, look how that performance doesn't change over time, right? Because of the way DynamoDB has modeled its database and how they make you model your data, that performance is gonna be the same. So you know that if something is performing well in your test environment or in staging or anything like that, or on day one of your application, it's going to work 6 years down the road when you have terabytes of data and all that stuff. So I think that's an interesting point about Dynamo. We'll talk a little bit more about how that works. I'll pause quickly. Any questions from folks about some of that intro stuff around why Dynamo? Again, this is mostly about operationally why you might choose Dynamo, apart from the data modeling stuff that we'll get into here.
Okay, thanks, Alex, for this first part. Let me just mention something. So Alex is going to give away 5 free copies of his book. So the first 5 people who ask questions will receive a free copy of the book. But of course, like questions about this, what we're talking about. So if you have a question, you can ask questions either in written or using your mic with audio, or Rinor Ayeti.
Përshëndetje, Alex. I had a question about cap theorem. When it comes around the cap consideration, where does it belong?
Yep. So DynamoDB is going to prioritize availability over consistency. When you're reading from DynamoDB, by default, that read is going to be an eventually consistent read. So basically, Dynamo is going to have your data on 3 different instances, basically like the primary instance and replicated to 2 others. When that read comes in, it's just going to choose one of those 3 at random, and so it could have not been replicated out to that particular instance yet. Now, you can opt into a strongly consistent read if you need to. It's going to basically cost you a little bit more in RCUs to do that, but you can choose a strongly consistent read there. That's on your main table. The other thing I would say, we're going to get into things called secondary indexes in a little bit, which are basically additional ways to index your data to handle additional access patterns. And those are eventually consistent only, most of the secondary indexes. So yeah, that's what it is. Like basically you can opt for strong consistency on your main table, but default is eventual consistency. And then on that secondary index, that's eventually consistent only.
Now we have Mimosa asking a question.
Sorry, I raised my hand, but then I realized it might be better to leave the questions for the end, because like I have some general questions like around tooling mainly. So yeah, maybe I can wait. I don't know.
Okay, sounds great.
Yeah.
Okay, but you asked the question before in the beginning, so you will get a book too. So we have two
Yeah,
books given away. Yeah.
I shouldn't get all the books. So.
Yeah. So if nobody else has any other questions for this segment, we can go to the next one.
Cool. Let's do it.
Are we cool? Yeah, let's do it.
All right, so let's get into the basics of data modeling. And I want to start off with terminology first, just so we're on the same page there and sort of compare it, especially if you're used to a relational database, some of those things. So 4 terms I like to talk about with DynamoDB. It's going to be table, item, primary key, and attribute. And we'll walk through this with an example just so you can see what these are. So here's some data I might have in my application. These are some users, right? Some users in my application. I have myself and then 3 folks that work for Amazon, Jeff Bezos, Jeff Barr, Warner Vogels. If you look at all this data together, that's going to be called a table. So all the data together is going to be a table, similar to a table in a relational database, but different in some ways as well. And if you look at an individual record in this table, that's going to be called an item. So I've outlined here in red this Alex Debris item. This is my user, right? Similar to a row in a relational database, a document in MongoDB, and it's called an item in DynamoDB. Now, when you create your table in DynamoDB, you need to specify what's called a primary key. And every item that you put into your table needs to include that primary key on it. And you need to uniquely identify each item in your table by that primary key. So here on the left here, I have this primary key. It has a partition key of username. And you can see each of those values are unique, right? Because you can uniquely identify each user by that username on your table. So that's what I have for the primary key here. In addition to that, you can also have attributes on your table. Attributes are going to be sort of like columns in a relational database, but the big difference is you don't have to declare these attributes or columns up front like you would in a relational database. So DynamoDB is schemaless in the sense that it's not going to enforce your schema for you outside of that primary key that you have to declare and include on every item, but everything else you don't have to declare. So this doesn't mean you shouldn't have a schema. You should absolutely have a schema, but you're going to have to validate it in your application logic rather than relying on your database to do that for you. So these are different attributes. Every attribute on your DynamoDB item is going to be typed. So it can be a string, it can be a number, it can be binary, it can be also like complex things like maps or lists or sets. So you can have complex attributes in there. I'm gonna pause for a second because Laszlo's got a good question. I'll just answer that one now. How does Apache Cassandra compare to DynamoDB? Very similar to DynamoDB, actually, probably the most similar to Dynamo. Basically what happened is like, in the 2000s, Amazon.com retail made this internal database that they called Dynamo. It was used to power some of their like very high traffic applications, shopping cart, different things like that. So they built that. They released this paper on Dynamo that everyone could read some of the principles on how it works, how it scales. Some of the engineers that worked on it went to Facebook, used that paper, and made Cassandra at Facebook. It then got donated to the Apache Foundation, but it's very similar to Dynamo. And then AWS actually made a service, DynamoDB, that's sort of based on Dynamo as well, different in some ways. So this is an evolution of it. So they forked a little bit in terms of what they do, but very similar type things. The primary key is going to be very important for each one. Attributes are going to be sort of similar, right? The schema-based nature. A lot of the concepts in data modeling are very similar between the two. So yeah, good question. All right, keep rolling with the vocab here. I talked a little bit about primary key. You want to talk more about that because the primary key is just super important with Dynamo. So there are 2 types of primary key. First, there's a simple primary key, which just has one element. That's a partition key. And there's also a composite primary key, which has 2 elements, a partition key and a sort key. So going back to that example we already had with our users in there, that was an example of a table with a simple primary key. It had just that one element, that partition key of username. I could also make that table a composite primary key. So let's do that here. Here, this table has a composite primary key. You can see there are 2 attributes there. I have a partition key of employer, and I have a sort key of username, right? So now each item is going to have both of those. One thing I need to say is that primary key needs to still uniquely identify each item. And you can see down here, right, like a bunch of different items can have the same partition key. Like we have here, a few of them have the same employer, Amazon Inc. But because that sort key is different, that username is different, it's the combination of those 2 elements that are going to make up the primary key, and those are all unique for those particular items there. If you're doing sort of more complex applications, you're almost always going to be using that composite primary key. That simple primary key is really just for key value type operations. So if you want to get a single item at a time, you can use that, but otherwise you'll use the composite primary key. One thing I like to talk about is what I call DynamoDB's guiding principle. And this isn't in their marketing docs anywhere. This isn't they haven't sort of announced this anything, but I think just all the decisions they make with DynamoDB, all the features they release and more importantly don't release with DynamoDB are all sort of based on this, right? They do not want to allow operations that won't scale. And if we go back to that scaling chart that I was talking about before, DynamoDB basically wants to enforce that very flat scaling chart where performance is going to be the same at 1 gigabyte as it is at 1 terabyte, right? And if you think about the applications that Amazon.com was building, what was, if we talk back to the Dynamo paper, they were seeing their Oracle databases slow down as they got more and more traffic on the shopping cart, on the orders page, things like that, all the inventory, stuff like that. So they wanted something that would scale really well and sort of force those scaling decisions up front rather than sort of down the line where you have this slower curve and you find out it's not going to scale as well. So I think that underlies all of DynamoDB's design. And so let's move into what I call SQL versus NoSQL, right? If you're coming from a SQL relational world, how is NoSQL different? It's not just this schemaless thing. I think a lot of people got hung up on the schemaless nature of NoSQL, right? Sort of from MongoDB's marketing, but NoSQL is about a lot more than that. It's really about scaling in that chart I showed earlier. So SQL versus NoSQL, how is NoSQL different? First of all, the importance of primary key is going to be very important in NoSQL, right? If you're used to your relational database, you can sort of query based on any column you want. You can add all these different indexes and query on it no matter what it is. With DynamoDB, that's not the case. So going back to our table with our composite primary key that had those two elements, the employer and the username, we can query with those primary key attributes very efficiently. So it's easy for me to go to this table and say, hey, give me that item, Alex Debris in the Debris LLC employer, and pull that back. Or give me all the employees that work for Amazon. I can do that very easily. But I can't query on those other attributes, right? It'd be very inefficient for me to go here and say, hey, give me everyone whose first name is Jeff, or look up the user that has this particular record. So as this table is currently structured, it would be inefficient for those. You'd actually want to rely on your primary key in almost all cases. The second thing that's interesting about NoSQL databases is they generally don't have a join operation. DynamoDB doesn't have a join operation. And to understand that, I like to think about how Dynamo is working behind the scenes. And this is like, again, that scaling discussion we talked about before. This is how DynamoDB is scaling. So when you think about a relational database, you think about like this one big instance that maybe has all your data and it has to handle all your queries. And maybe you think Dynamo is the same, but it's not. DynamoDB is not going to be all in one instance. What they're going to do is they're going to have that DynamoDB front end for you, but behind the scenes, they're going to partition your data across these different nodes. So in this case, I have two partitions, partition 1, partition 2. Each one is going to hold a subset of my data. Generally, they're going to try and limit a partition to about 10 gigs of data. So maybe I have 15, 20 gigs of data total. I have these two different partitions. Now, when a request comes to DynamoDB, let's say someone wants to insert a new item. They're going to use the put item operation. They want to insert Andy Jassy, right, as a new employee of Amazon. It's going to hit that DynamoDB front end there. And the first thing that DynamoDB front end is going to do is going to hash that partition key value. So the employee here is Amazon Inc. It's going to hash that particular value and then figure out which partition that item belongs to, right? So in this case, it says, I hashed Amazon Inc. Those items are on partition 1. I'm going to go over to partition 1 and write that value there. So now imagine, I add more data and now I have a third partition or 6 more partitions or thousands more partitions. The great thing about this whole setup and how it works is that first step that happens there when it hashes that partition key value and figures out which partition it belongs to, that's going to be a constant time operation, right? Because you're looking up a value in a hash map saying, hey, where does this belong? And then I can go reach out to that partition. So immediately what you're doing is if you have a 20 terabyte table, you're narrowing it down to a 10 gig partition to where you can go and play around in that partition rather than messing around with 20 terabytes of data, which is a lot of data and can slow down. So that's how Dynamo is going to give you that scaling over time. Question from Eco: Does primary key have a type? Yeah, each attribute in Dynamo will be typed, whether it's a non-declared attribute or whether it's actually a primary key. So primary key elements need to be either string, number, or binary. You can't use those complex types for primary keys, but yeah, string, number, or binary for those. So anyway, this partitioning concept is really important for understanding how DynamoDB works. So now we have these two sort of interesting principles about Dynamo, especially how it differs from NoSQL. What are the implications of that? And there are a couple implications that are really important here. Number one is this tool called secondary indexes, which I talked a little bit earlier when we were talking about consistency. But if we go back and talk about how primary keys are so important, you can only query those primary keys. That can be useful for that first access pattern. But what if you have additional access patterns, right? What if you want to query off something like the email or the last name or the username, something like that? How would you do that? What you can do is declare what's called a secondary index on your table. And you declare it on your table, you give it like basically a new primary key, and Dynamo is going to copy that data from your table into that secondary index that you can query on. So if you look here, I have this data here, but if I look at my secondary index, this is what it's going to look like, where I have this different primary key. It has a partition key of email. It has my exact same data. It's just been copied into it, replicated into it, and I can query that and enables these additional access patterns. So the key on secondary indexes, hold up one sec. Let me finish this little segment and then I'll answer this question. So the key on secondary indexes is you have data from your base table, that main table is copied into that secondary index with a new primary key, and it enables those additional access patterns based on those primary keys. So you can use the query or scan, so read-based operations on that secondary index, but you can't write directly to a secondary index. You can only write directly to your main table, your base table, and it gets copied out to your secondary indexes. So I'll pause here. Questions?
Does primary key have a type?
That one I addressed a second ago, but yeah, each primary key attribute will be typed string, number, or binary. Yeah, and you have to send that up when you specify that attribute. So that's the first implication, right? Secondary indexes. The second one that's kind of interesting is you need to know your access patterns in advance, and you design your table for those access patterns. So this is different from a relational database where you think about all your different entities and you sort of normalize them, right? And make these different tables for all your entities. You set up the foreign keys between them, and then you think, hey, how am I going to access this? And you write your SQL queries to handle those access patterns. With Dynamo, you're not going to do that, right? You don't have join operations. You don't want to have so that's not going to work for you. So what you need to do is know your access patterns in advance and design your table for those access patterns rather than designing your table first and then thinking about access patterns. The third thing that we talk about with Dynamo, and this is a weird one, and I think really throws a lot of people, is that you'll probably put all your items in different entity types in a single table and use these generic attributes for your primary key. So this is going to diverge a little bit from what we've seen before, but if you have, product or customers and orders and products, things like that, rather than having 3 separate DynamoDB tables, you probably put them all in one table. So if you read about single table design with Dynamo, that might throw you. I want to walk through an example to see what that looks like, just to sort of ease us into this. So an example I might have here is like a SaaS application, right? I'm developing some sort of SaaS application. Organizations can sign up for my SaaS, and they're the one that's actually paying the bill. And then users can belong to that organization and act on behalf of that organization within my particular SaaS application. So let's start off by modeling organizations. And here's a table I have here that has 2 organizations in it, right? I have Berkshire Hathaway and I have Facebook. So 2 organizations in it. 2 things I want to call out here. Number one, if you look at the primary key, and especially the names of these primary key attributes, notice that I'm using very generic names for these primary key attributes. So instead of using something like organization name or username, I'm using PK for partition key and SK for short key. And the reason I'm doing that is because I'm going to have a few different entity types in the same table. And so they're not all going to have the same attributes, right? Like a user is not going to have an org name, or an org name is not going to have a username, things like that. So what I'm doing is giving it these PK and SK attributes instead. Now, if you look at the values for those, you can see I have like these little prefixes on them. So I have org hash Berkshire here, org hash Facebook. And what this is doing a few different things. First of all, it's identifying the type of entity it is. This is an organization entity, right? And it'll prevent conflicts across different types that happen to have the same values for those. It can also help for organization and different things like that. So you're often sort of identifying your different item types using these little prefixes here. So we have that. Now I'm going to add in some user items here. So I've got this. This is my same table. I've still got those two organizations in there, Berkshire and Facebook, but now I've added in these user items outlined in red. So Berkshire has Warren Buffett and Charlie Munger, and Facebook has Sheryl Sandberg in there. A couple things to note there. Notice how the primary key is different. The value is different for those user items, right? They start with user hash and the username for that sort key rather than the org hash, org name. You can also look at the attributes for those user items. You can see how there's username and role, right? Things that matter for that particular user are on that user item, whereas on the organization item, it has org name, subscription level, things like that, things that matter to that organization. So that's where that schemaless nature of Dynamo comes into play. You don't have to have the same attributes for every item. Last thing I want to say is you'll notice that you see lots of different items with the same PK value are going to sort of be grouped in this modeling thing I have here, and that's called an item collection. All the items that have the same partition key are going to be grouped together in an item collection. And the important thing about items with the same partition key is they're all going to be located near each other. Remember how we talked about how DynamoDB's partitioning works, right? Every item with the same partition key is going to be on the same partition because of how they're hashing that partition key value and then sending it to the same partition. So it's very efficient here to query based on that. If I want to query for all the things in Berkshire, I could do that. I could send that query operation in with just that PK. It's going to say, hey, those items are located on on partition 3. Very efficiently get all those items for me. Last thing you'll notice here is that there are different types of entities in this item collection. So I have an organization item in there. I have some user items in there as well. We're going to see in the one-to-many stuff a little bit later about why we might do something like that. But it's kind of interesting how you can make these different collections. So last thing I want to say about SQL versus NoSQL is you'll need to get comfortable with some amount of denormalization, which it definitely feels weird. You know, what I was just saying with all items in a single table using these generic attributes, that feels weird. It also feels weird to denormalize your data because we've learned through all these normalization rules in SQL, like, you know, don't duplicate data, don't have like complex attributes, you know, have like a scalar value for a particular column value or things like that. With Dynamo, that's not going to be quite true all the time. So you need to get comfortable with some amount of denormalization when it makes sense, when properly used, just to help with modeling in Dynamo. So those are the big implications. Any questions on that section, on sort of the basic fundamentals of Dynamo and some of the concepts there?
Mm-hmm. We have Emirullah.
Yeah.
How would data migration work in this setup?
Yeah, sure. And can you tell me more about, for data migration, are you talking about like if I need to add new access patterns? Is that what you mean by migrations?
Yeah, new access patterns, maybe new structure.
Yep. Yeah, great question. So I get that question a lot because a lot of people are nervous about it. And I would say, like, it sort of depends on the type of migration you're doing, right? If you're adding a new type of item into your application, into your table, you don't need to do anything to your current table because this is all additive change. Same thing if you're adding like a new attribute to existing items that you're not querying by. You don't really need to go change all your existing ones. You can just have in your code sort of a default value where if you read back this user item and it doesn't have a birth date or whatever your new attribute is, you can just sort of have a default value there of what that'll be. The harder ones are like, hey, I need to access existing items in a new way. They have an attribute, I want to index it in a new way. How do I make that change? And that is a more involved change, but it's also like not as hard as you think it is, right? Basically what you're going to do is you're going to run an operation that scans your table, looks for the type of item you need to change. So if I need to, you know, re-index a user item in some way, every time I find a user item, I'm going to issue an update operation on that user item to re-index it in this particular way and handle that new access pattern. So it's like a 3-step process: scan, locate, update, right? And it's very formulaic. And when you're writing one of these, you know, you write it once, it works for basically every time you do this, because all you have to do is like change the update logic a little bit, change the location logic a little bit, and otherwise it just does it for you. And it's like kind of a mechanical operation. So it's, you know, it's different than a relational database, but it's not as hard as some people think too. And this is something I cover in the book. If you want to check that out, there's a whole chapter or a couple chapters on migrations. So great question.
So we have two questions, one in written and one request, a raised hand. Actually, Mimosa also has raised her hand, but I don't know if it was from before. So we have Rinar and the question on the text question from Tony Faton.
Yeah, so Tony's asking, need to find a unique user ID, run a script. So basically, you need to find a unique user ID, but it wasn't the primary key value. Is that what you're saying?
Yes, correct.
Okay. So yeah, the main thing I would say is like, hey, if you want something to definitely 100% be unique, you should model that as your primary key. And that's how, like username, I would recommend using that as a primary key, because then you're saying, hey, this is unique across the entire table. I can't have multiple items with that primary key. Now, if it is a secondary attribute that you want to have unique, it's a little harder to do. You could index that attribute so that you can query by that. And if you want to insert someone that has that one, you could make a query against your secondary index, find if anyone has that, and then insert an item. If not, you do get some data consistency issues there because, as we were talking about earlier, secondary indexes are not strongly consistent, and you could even have a race condition too, where maybe it wasn't true when you queried, but now someone else has inserted a record with that item. So it's a little harder to maintain outside of a primary key, but you can do that. But the big thing here, the reason Dynamo is not going to allow you to sort of just scan your entire table and find an item with a particular value in like an ad hoc query sort of way is that scaling they want to have, right? That, as you add more and more users, that's going to get slower and slower unless you put it in a secondary index or something where it's indexed according to that. But just sort of free-form queries against your table, that's going to be pretty slow.
So Rinar and Mimosa, who wants to go first with a question?
I guess I want to go a little bit back to the migration topic, not exactly on that, but I'm wondering if you ever had the need to kind of move away from NoSQL into SQL. Let's say you suddenly got requirements that put in a lot of relations around data, and I'm wondering, did you migrate or did you just extend kind of the properties that you used, or how did you solve that, if you ever had that? Because I feel like application needs always change. They're not the same as when you start. So yeah.
Yep, great question. And the first thing I would say is, like you mentioned, like if you got data with a lot of relations, and I think people think, hey, you can't model relational data in DynamoDB, and that's not the case. So the next section is all about one-to-many relationships and how you model in DynamoDB. So Dynamo can totally handle relational data. You just need to sort of model it more specifically for that, understand some of the different trade-offs. The biggest thing I would say is like using DynamoDB is a mindset shift in how you model data. And there are some like upsides and downsides. And I think that's true of like every single database, right? With Dynamo, I would say the biggest upsides are going to be that completely flat performance curve, how it's going to be just completely consistent over time. And the other upsides are going to be some of those serverless benefits I talked about before. If you're using serverless applications, there's some really nice things about using DynamoDB that you just can't get in a relational database. There are even additional problems with relational databases that I didn't cover in serverless applications. So you might choose Dynamo for those reasons. But I think, like, as we've talked about with the migration stuff, it can be hard. It can be harder to add additional access patterns to your data. So then that's the downside of Dynamo. There's also a learning curve to Dynamo, especially if you're coming from a relational world. It's just different. So you need to understand those trade-offs. And there's no magic bullet for a database. And you need to choose, hey, which sort of batch of things am I grabbing? Like the nice thing about Dynamo is like 90% of your days are going to be better because of Dynamo, because you don't have to worry about scaling issues. You don't have to worry about operational issues and things like that with serverless. But then you get like these lumpy times where it's like, oh, I need to add a new access pattern. Oh, up front, I need to learn how DynamoDB works. We have to spend a lot more time than you would comparatively with a relational database. And sort of like, which trade-off do you want there?
Yeah, actually, my first question was more like it felt like a sinful question, because I was going to ask, have you ever related to DynamoDB tables? I don't even know if you do that. Like, do you relate tables, or how do you when you do relations?
I mean,
how do you?
Yeah, you can't do like actual joins, so the database isn't going to relate those tables for you. I mean, sometimes what I see people doing is sort of modeling like a relational database, but in DynamoDB. So everywhere they have a table in a relational database, they have a table in DynamoDB. The bad part there is like now you need to do your joins in your application and add a lot of network hops in there, where you say, hey, go give me this user by username. It's going to pull back. It's going to give me that user ID. And now I can go get all the orders for that user based on this particular user ID, but those have to be like sequential calls. So you have to go get that user ID first and then do it. And it's just going to be a slower operation for you to do that in code, and especially just all those network hops that are going to have to happen for it. So I try to recommend against that as much as possible. What I try and say is, hey, reduce each access pattern you have, try and reduce it to a single call to Dynamo if you can, or if you have to do multiple calls, see if you can do them in parallel rather than sequential. And sometimes sequential is required, especially for many-to-many relations. But I think what you want to do is try to avoid doing that relational SQL-based normalization modeling in Dynamo, because then you're going to have that sort of waterfall of requests.
Cool. Rinar?
Hello again, Alex.
Hello.
My question is about how does DynamoDB computes the query time? When, like, for example, if you have an key value pairs of emails and you have 1 million data stored and you are searching just 2 of them. Now, if you have another scenario and you have like 1 billion key value of emails and you still are searching about just 2 emails, is this time query equal or not?
Yeah, remember going back to this, right? If you have a million emails, maybe you have 2 partitions. And if you have a billion emails, maybe you have 50 partitions. But that first step, that request router in blue there, right away, it's going to know which partition you go to. So you send in, say, hey, I want this email. It's going to hash that partition key and go exactly to the right partition for you. So then it doesn't matter how many different partitions you have. You could have 1 partition or 1 million partitions. It's going to take the same amount of time, because then it's going to go to that partition, which is going to be indexed accordingly and find that value very quickly there. So it's basically, doing a get item operation is a constant time and operation in DynamoDB, regardless of the number of items that you have on it.
Yeah, thank you. I just wanted to make it sure that it was the one that I show in slides, complexity of 1.
Yeah. This one? Yep. Yes.
Yeah, this one.
Yeah, that's a constant time operation. If you're doing, once it gets to that partition, it's working on 10 gigs. If you have multiple items that have the same partition key and you're sort of finding which short key you start out there, that's going to be an O log n operation, but it's also going to be O log n on a much smaller amount of data, maximum 10 gig of data. So it's going to be pretty quick, all that. The big part is going to be this O1 part, right, where you're going from gigabytes and gigabytes or terabytes down to 10 gigabytes immediately with an O1 operation. So it's going to scale pretty well there. I think that's the important thing to know about Dynamo.
Hello, Rinar. Did that answer your question?
Yes, it did. Thank you so much, Alex.
Yep, great question. I'll keep going into the last section. Yep. And again, feel free to drop questions as you come, and we'll have Q&A at the end as well. So this has been great questions so far. So let's talk about one-to-many relationships, because, hey, if I don't have joins, how am I going to do one-to-many relationships? I like this section because I think it brings it down, right? We talked about single table design. You see all this weird modeling. You're like, what the heck am I doing? I think this makes it more practical in terms of understanding what's going on here. So I want to talk about one-to-many relationships. What is a one-to-many relationship? It's whenever you have some sort of parent entity that has child entities that belong to it, right? So an office could have multiple employees. Multiple employees work at that one office. It could be customers and orders, right? If you have an e-commerce store, if I have Amazon.com, I sign up to the customer, I make multiple orders. At least they're hoping I make multiple orders over time. Or that example we already had with our SaaS application, right? An organization signs up for your SaaS application, and then multiple users belong to that SaaS organization, or to that organization can act on that SaaS application for that organization. So that's what a one-to-many relationship is. In SQL, you generally model it, with a foreign key, and then you do your joins to make that happen. But we're going to see how to do it in Dynamo, and it really depends on your needs, your requirements, your situation. So I'm going to walk through 5 different strategies that I've seen. You might even see other ones out there, but these are the 5 I see most commonly. So first one, let's do denormalization with a complex attribute. So when you're talking about denormalization, one of the rules is in like a relation, or sorry, when you're talking about normalization in a relational database, one of the rules is like a column value should be a simple value, like a string or a number, like a scalar value, rather than a list or a map or anything like that. We're going to get away from that a little bit in Dynamo. So let's go back to our SaaS application that we had before. I want to add another one-to-many relationship. And let's say when an organization signs up, it can have multiple different payment methods registered, right? That organization needs to pay the bills, and maybe it has a bank account, but it also has a credit card or something like that if it fails. So they can have multiple payment methods. How would I model that? I would do this. So what we have here, it's a little hard to read, but if you outline in red there, you can see I have this new payment method attribute. And if you look at the value there, it's a map. So map is containing multiple different values. I have the default payment method and a backup payment method, all that stuff. So what I'm doing is I'm denormalizing directly onto that organization object and adding this complex attribute there. So when should I use this strategy, this denormalization complex attribute strategy? It's good when you don't have an access pattern on the related items directly. So the related items in this case would be those payment methods, and I'm never going to have an access pattern where I say, hey, I have this credit card or this bank account. Can we figure out which organization it belongs to? Like, that's not how we're going to access this data. We're going to access this data in two ways, right? We're going to, at the end of the month, we'll go through each of our organizations and we'll find the organization and we'll look at their payment methods and charge them, right? But that access pattern is by organization, not by payment method. The second one would be, hey, if someone wants to view their different payment methods and edit them in the console, they can do that. You show it to them, they'll allow them to edit it. But again, that's within the context of an organization. So I don't have any access patterns on the related item directly. The reason I say this is because you can't index a complex attribute like a map or anything like that. It has to be a string or a number or binary value. The second thing there is when you have a limited number of related items, right? So, and this is because each DynamoDB item is limited to 400 kilobytes. And so you don't want to have this attribute that just keeps growing and growing and growing and then hits that DynamoDB item limit. An example here would be like customers and orders, right? If I'm a customer, I'm making multiple orders, you wouldn't want to have like an orders attribute on that Dynamo, that customer item, because as I keep adding more and more orders over time, at some point I'm gonna hit 400 kilobytes and you're gonna have to say, sorry, you can't make any more orders because we modeled our database incorrectly, which is gonna really make your business folks mad. So that's not when you want to do that here. In this case, like, right, we have, it's not like someone's gonna have 1,000 or 5,000 payment methods, right? They'll have 1, 2, or 3, or maybe 5, but you can limit that pretty easily and not have an issue. So it's fine to denormalize it that way. Let's move on to the second strategy, which is another denormalization one. This one's duplication, right? And usually when you're normalizing data, you don't want to duplicate data. If you do duplicate data, you sort of pull it out into another table and refer to it in these different spots. But we're gonna get away from that a little bit here. The example I have is maybe you have a library or a bookstore or something that contains books, and you have a one-to-many relationship between an author and the book itself, right? And we're going to ignore that, multiple people can write a book, just for the simple example. But when you're fetching that book item, sometimes you want information about that parent item, right? And in a relational database, you would join those together to get information about that, but we can't do joins here. But when you fetch a book, you might want to get the author's name, the author's birthday, things like that. What we're going to do is we're just going to denormalize this data, duplicated information about the author onto each book item here. So I have 2 books here by Stephen King. I have it, I have The Shining. I'm just going to copy the birth date onto each of these items rather than sort of have it stored on a separate item. So that's what we're going to do here. When is this a good situation to do? Number one is when that duplicated data is immutable, right? Like, one of the reasons you want to normalize and not duplicate data in a normalized database is for data integrity reasons, right? You don't want to have this data that if you change it, if someone wants to change it, they have to go change it, in 4,000 different places. But in this case, like, Stephen King's birth date is immutable. It's the same today as it was yesterday, as it's going to be tomorrow. Like, you don't have to worry about that birth date changing, so it's okay to duplicate. You can also do it, if that duplicated data doesn't change very often, maybe it changes once a year max, or maybe once a lifetime, or if it's not replicated very much here, right? So if you're only duplicating that data across 3 or 4 or 5 items, it can be fine to go find those items when they do get updated, make those changes accordingly, and be fine. The situation you don't want to use this is if it's data that changes kind of a lot and is duplicated across a lot of items, because then you just have all this churn and some data integrity issues as you're trying to keep this updated. So those first 2 were both about denormalization. Now we're going to talk more about structuring your item collection properly, right? And the first one we're going to talk about is using a composite primary key. plus that query operation. So I said the query operation can operate on an item collection, right? Which is that all items with the same partition key. So what we can do here, let's say I have an access pattern in our SaaS application where I want to get all the users for a particular organization. But when I do that, I also want to fetch that organization itself because there's some information about that organization that's useful to return back, maybe the name or the subscription level, something like that. I can do that here. You can see what I've done is I've sort of organized my item collection where I have that organization item come first and then the user items below it. So when I go fetch those users, I fetch all that at once. I have all my user items, but I can enrich them with that organization item as well. And what I've done is basically pre-join my data. I've written it in a way that's joined at read time rather than sort of doing that join at read time. So I'd say this is a pretty common way to do these one-to-many relationships if you need to do that. A second and related one is going to be secondary index and query, and it's going to be very similar, but it'll be used when you can't do the composite primary key. So let's go back to that example I just had with the SaaS application. We have organizations, we have users. Let's add another entity and relation in here. So let's say each user has tickets, right? So maybe our SaaS application is like Zendesk, where each user is sort of assigned tickets and they need to handle them. And you might be tempted to model it like this, right? So I've added these new tickets in here. These tickets belong to Charlie Munger. And what we've done is we've just sort of jammed them in right under Charlie Munger. So you can see I could do a query right on those items right there, and I could get the user items and the ticket items. So if I had a query that would say, hey, give me all the tickets for a user, I get all those ticket items and also get that user item just like I just did with that organization and user, same sort of pattern here. The problem here is, remember that I also had this access pattern, get all the users with that organization item. I want those lined up all next to each other. But now if I go to my table and look at it, I've sort of rearranged my items to where I have that organization item, I have a user item, but then I have all these tickets, and then I have the next user and all their tickets, and the next user all their tickets. So if I want to handle that first access pattern, my organization and all the users, I'm going to be getting a bunch of junk tickets in there as well that I need to throw out, which isn't going to be very efficient. So let's scratch that and let's do it a different way. What we're going to do here is now we've added our tickets down below here. They're in their sort of own item collection. It makes it very easy for me to find an individual ticket by ID. But now I've also added these other attributes. These are GSI1 PK, GSI1 SK. So that's global secondary index. We talked about secondary indexes. We're going to use these secondary indexes to re-index our data in a particular way. I've added these GSI1 PK, GSI1 SK values to the user and the ticket items here. And one thing in particular, if you look at Charlie Munger and you look at his tickets, they have the same GSI1 PK value, which means in my global secondary indexes, they're going to be joined together like this. Let's go look at our secondary index. Now we've rearranged that data according to that secondary index, and you can see that Charlie Munger and his tickets are all in the same spot. I can easily go and query that and get Charlie, get his ticket items, and get those back to me. So secondary index and query, very similar to that composite primary key pattern. The big difference here is this is good when your primary key is already being used for something else. You can't use that for this pattern. All right, last one, composite sort key. This one's a little different. I don't see this one very often, but I think it's worth talking about. So let's imagine you have a store, or like a store that has locations, and these locations are all over the world, right? So they're in different countries, and within those countries, different states, cities, zips, all that stuff. And maybe you have access patterns at different levels of granularity. Sometimes you just want to say, hey, give me all the stores in the US, right, by country. And I can do that very easily by just going to that partition key and getting those. Or maybe you want to say, within a particular country, all the stores within this particular state, right? So in the state of New York. And I can do that very efficiently because what I have is this sort key that has state, city, zip. It's all sort of jammed together, and I can query at different levels of granularity. Or maybe, I want to do state and city. So I want to say, hey, within New York City, and I can do a query there that just matches the beginning of that sort key and gets me those. Or maybe a particular zip code, right? And I can match a particular zip code and get all the stores within that zip code. So what I have is a composite sort key. In that sort key, I've sort of jammed a bunch of values together in like increasingly granular ways, so I can search at different levels of granularity. So this is good when you have multiple levels of hierarchy: country, state, city, zip code, right? Those are different levels of hierarchy. And when I'm searching at a particular level in a hierarchy, I want all the sub items, right? Because if you go back to that previous access pattern we have, I had multiple levels of hierarchy. I had organization, user, tickets. But when I'm searching at one level, I don't want all those other related items. So that became a bunch of junk in there. But in this case, I actually do want all those, so it worked out well. So that's where you might use composite sort key. I'll summarize this up, and then we can ask questions about one-to-many relationships or about anything else you want to talk about with DynamoDB. But again, just to cover what we talked about, that first section, why DynamoDB and serverless was less about the data model and more operationally. Why are a lot of people choosing DynamoDB in their serverless applications? Once we got a feel for that, what in the nice benefits you go there, then we talked about DynamoDB data modeling because it's different than a relational database, right? We talked about vocabulary, we talked about SQL versus NoSQL. We saw that first example about sort of single table design. And then to bring it back home and give us some real examples, we looked at one-to-many relationships, 5 different ways you can handle those in DynamoDB. With that, take any questions. Also, you can just find me sort of anywhere, any of these places. But yeah, happy to take any questions.
Cool. Does anybody have any questions? Because the presentation is finished, but we can now go on with the Q&A.
I see Amy and Liberian.
Yeah, Amy, you can go.
So what's the case that you definitely don't want to use DynamoDB in?
Cases where you definitely don't want to use DynamoDB. I would say if you have like full text search requirements across your entire database, or if you have pretty complex filtering requirements, again, across your entire database where you can't like sort of narrow it down to a partition first, like an organization, and then do those sort of filtering. But if you have these very flexible filtering requirements, that's gonna be tough for DynamoDB to handle, and it might be better to use something like a relational database there, or like Elasticsearch for full text search. You're gonna run into like sort of the scaling problems, but maybe that's not an issue for you, so it doesn't matter. So I think that's fine. I would also say just like for any ad hoc queries you have. So if you're thinking about like analytics, right? If you want to be running ad hoc queries against your database to find out like who are the highest spending users in the last month or something like that. Just these ad hoc questions. Dynamo is not going to be a good fit for that. You can export your DynamoDB data and then query it in Redshift or Athena or something like that, but just like doing it in Dynamo itself is not going to work for that. Those would be the big ones. And then I would say, there's this big messy middle of like 80% of applications can use Dynamo, can use a relational database. The approaches are going to be different. The trade-offs are going to be different, between those two. And it more sort of depends on your situation, your comfortability with DynamoDB, the learning curve, things like that. But I think there's a big section where it's like, hey, you can use Dynamo, you can use relational. I'm not here to make you use Dynamo and tell you that's the only one you can use, but it sort of depends on what you want to use there. Does that make sense?
Yeah. Yeah.
Liberian, do you have a question? And then Rinor.
What's the point of keeping the same field twice as an attribute and as an index?
Hold on. So let me go back to make sure I understand this one. Are you talking about like here where it includes some of the same values there?
Yeah.
Yeah, that's a good question. That's one thing I covered in my book. It's sort of personal preference. I would say like, as you'll see, like in the sort key for the users, it includes the username. So why do I also need a username attribute? I think it's easier to work with like in my sort of application to actually just go straight to the username property and not have to worry about changing it or messing with it. So that's nice. You will pay like a little bit of like extra storage costs. You're duplicating some data there. The other thing I would say is like, sometimes you might lose fidelity into that attribute. So if you look at like the sort key here, I have it in all capital letters. And part of the reason that is because like Dynamo is going to sort, let's go graphically, which means, basically alphanumerically, but also all capital letters become before all lowercase letters. So like my last name is Debris, D-E-B-R-I-E. So that would become like that capital B would sort of throw off sorting in some ways. So what I do is just like normalize that, make it all uppercase. But then if I make it all uppercase and I don't have the actual name duplicated somewhere else, I don't know what that actually is. Right? I've lost some fidelity into that data. So because of like enough of those little edge cases of where it's a little easier to work with in the attribute, you don't have that fidelity issue, things like that. I usually just generally duplicate it as a rule, but it's totally personal preference for you. If you have some attributes that won't lose some of that fidelity, like go ahead and don't duplicate it into your attribute if you don't want to.
Thanks.
Yep, good question.
And Rinar?
My question was, if I wanna move from DocumentDB database to key value pair database, is there any advantage that you wanna mention by looking on its performance?
Yeah, good question. So one thing I would like, just like a small clarifying thing up front, I wouldn't call DynamoDB key value. Like if you're using Dynamo in a simple primary key, then it is key value. But if you have that composite primary key, now you can get multiple items in a single request. It's not quite key value in the same way. But that little thing aside, like MongoDB versus DynamoDB, I would say like at a very high level, they're very similar. Mongo has Mongo has a partitioning scheme that's very similar to this, where it's like going to partition on some value and break it up and then have efficient queries and allow you to sort of scale outward that way. The one thing I would say about Dynamo and Mongo is like Dynamo is way more strict on what it won't let you do. Like Dynamo will not allow you to do operations that won't scale, where Mongo is like a lot more flexible on that. And like it's sort of designed for ease, I would say, and which is nice if you don't have sort of scaling problems. But what it can do is it'll give you that performance curve that we talked about with MySQL, where that performance can get slower over time. And like one thing would be, you basically can't query Dynamo efficiently using something that's not a primary key. But if you query Mongo with something that's not in the partition key to split it up, what it'll do is it'll just execute that query on every single one of your partitions here. And then scatter, gather, combine the results, and return those to you. And it's nice because it's a lot easier. You don't have to think about it. But it also makes scaling up harder, because now horizontal scaling is hard, because even if you add additional nodes, they're still going to get all those queries that are sort of scatter gathering, so that like it's hard to horizontally scale unless you're careful in Mongo. So with Mongo, you need to be a little careful. Mongo or DocumentDB, same thing. You need to be a little careful on like, am I going to avoid those scatter gather queries, and be very careful on that? Or do I not have scaling problems? I would also say that DynamoDB's operationally is just like a little bit more hands off. I mean, Mongo's pretty good about that. DocumentDB, they're getting better with those hosted solutions, but DynamoDB is like completely hands off. The only thing you have to say is like read and write units, or on demand if you want to. You don't need anything about that. So a little bit there, but you know, I'd say that sort of philosophy is going to be a big difference there.
Thank you again, Alex.
Yep, great question.
So does anybody else have another question? So until you do, okay, we have two people. Let's go, Mimos, and then Isa.
Yeah, I have a very generic question, maybe personal question, actually. I'm wondering, back to the tooling that I said I was going to ask about, I'm wondering what kind of tools you're using for serverless in general. I mean, infrastructure as code tools, because there are so many out there. I'm wondering which one you prefer yourself.
Yeah. So I'm definitely biased. I worked for Serverless Inc. for 2.5 years. They're the company that makes the serverless framework. So I use that mostly. I love it. I would say serverless framework and AWS SAM are very similar. I think serverless framework, is a little more developer friendly in my opinion. I'd say SAM feels like a tool that was built by AWS, and they're just like not the best at developer experience sometimes. So, but they're generally pretty similar in approaches, and you can use either one of those. The other one I see coming up a lot is CDK, which is like
I was going to ask you about that.
Yeah, sure. So like Terraform, CloudFormation, Serverless Framework, SAM, they're all like declarative formats, right? You declare your infrastructure in YAML or JSON, something like that, and it'll sort of figure out how to provision it. Where CDK is more imperative, like a programming thing. It'll say, create this thing, assign it to a variable, then operate little things on that variable. And what it's going to do is generate CloudFormation under the hood. So it generates something declarative, but the way you interact with it is imperative. A lot of people like it. It gives you it feels easier. It gives you some type hints and things like that, because you can do it in TypeScript or Go or different things that have types with them. It feels more flexible. The big thing that I worry about is just like a couple ones. I think with imperative, it's harder to know what you're doing. In some ways, it's also like way harder to come into a project and understand it, because like every serverless framework project looks pretty much the same. Every SAM project looks pretty much the same. If you onboard into a new team and you look at that, you're like, okay, I understand where my functions are, where my other resources are, things like that. Whereas like with CDK, like everyone's a snowflake, right? Like I can write code totally different than how you write code and structure it totally differently. And it just like is really hard to figure out what the heck is going on, I think. So that's what makes me like a few things that make me nervous, but I don't know, CDK is really taken off too. I don't want to be like the Debbie Downer on that sort of stuff and say you can't use it, but like understand those trade-offs and the different trade-offs about those things and pick one that works for you.
Nice. Yeah, I kind of like the idea of CDK. I just I don't like two things. I don't like that it produces CloudFormation because I'm not a huge fan of CloudFormation. I prefer Terraform. And the other thing, I feel like it's ready. It's very good at serverless, but it's not so great at other things, like not ready yet. So the community is building on it, but yeah, I think it has some way to go around other things.
Yeah.
But yeah, thank you.
Yeah. Yeah, that's true. And like I would also say with like Serverless Framework or SAM that I more lean towards, like those are more focused on sort of serverless stuff, and everything else you do is just going to be basically CloudFormation, which I agree that CloudFormation is like a worse developer. I would say like the developer experience difference between Terraform and CloudFormation reminds me of the developer experience difference between Serverless and SAM, right? Like I think third parties are just a little better about doing sort of developer experience stuff than AWS is itself. Serverless is going to compile down to CloudFormation, so you're still dealing with it in some level, but you don't need to know all the nitty gritty about CloudFormation, and same with CDK, which is nice. So yeah, good questions.
Cool. And now Isa has raised his hand. Thanks, Mimos. Yeah. Thanks, Alex.
Hi. I wanted to know if hybrid architecture, like having DynamoDB for write-heavy operations, and then doing some offline processing into a relational database with aggregation or something. Do you see that architecture as a possible one, and what do you think about it?
Yep, absolutely. I see things like that all the time where people want to use Dynamo to ingest that data, maybe prevent some uniqueness stuff, but basically just ingest it. Nice thing about Dynamo, it has DynamoDB streams where you can basically just set up a stream of change logs. So every time you make a write operation to Dynamo, whether that's inserting an item, updating an item, deleting an item, you're just going to drop a record into that stream, and then you can process that like you would a Kafka stream, a Kinesis stream. You can hook up a Lambda function to it and process those in order, and you can insert those into a relational database or Elasticsearch or S3, via Kinesis Firehose, anything like that. So it's a nice way to like hook into that stuff and send it to other systems and enable these additional access patterns. So I see that quite a bit. I would say I mostly see it for sort of more unique access or unique stuff like Elasticsearch. I need full text search, and that sort of needs to be like a totally different database type, or analytics. So, either Redshift or S3 and Athena, something like that. I don't see it quite as much for like a sort of OLTP relational access patterns like a Postgres or MySQL. Generally, just because like if you've sort of bought into Dynamo, you're generally like into Dynamo, but it's not that I've never seen it. I just see that one more rarely.
Thank you.
Yeah, good question.
Thanks. Any other questions? You don't have anything written? Just so you know, the people who have asked the first questions and received the free book are Renora Ayeti, Mimos Ladrovci, Laszlo, Onetomany, Ekoman, and Emrullah Recepi. So, until somebody else asks a question. So now we have Mimos again and Isa. Who was first? I didn't know. Okay, let me see.
So in my case, I have like a lot of questions if we have time, like things in general. And so if you have time, I can ask questions. If you don't have time, I can stop.
So as per our plan, which we put also in our AWS user group in the meetup, we are planned to continue until 10:02. So 10 to 8 p.m. So we have a few more minutes, like 20, 26 more minutes, something like that, if you have more questions. So you can shoot. I think Isa raised his hand first. If he has a new question, or Mimosa, whichever wants to go first.
Not for now.
Okay, cool.
Mistakenly.
Cool. Yeah. Then let's go, Mimosa. Shoot.
Yeah. So not necessarily what you said. I'm more like what you didn't say. I was wondering if you want to say something about the super fancy global tables. That's like something you cannot do with anything else, not with RDS, not with other things, as far as I know. So I think that's kind of interesting to mention, maybe.
Yep. Yeah, good point. So Dynamo has a concept called global tables where you can create, a DynamoDB table is scoped to a region generally, but with global tables, you can create tables in different regions and sort of they will handle replication between them. So if you have one in EU West 1 and US West 1, you can have tables in each of those. Rights from US West will get replicated to EU West, rights from EU West will get replicated to US West. So a really like nice hands-off way to do that sort of replication across those and handle that, and then you can read from whatever is closest to you, which is awesome. So a lot of people checking that out and loving it. You'll have some. We talked about consistency earlier. You're not going to have strong consistency across regions for those, but replication lag is usually pretty small, less than a second or two. So it's a pretty awesome way to have like basically global data without you having to maintain this infrastructure, which is a pretty tough thing to do generally.
Yeah, I think that fact that you can write to many masters, as they used to call them, it's rare and it's difficult, and people want it because then you're closer to, in a region that is closer to your users. So that's very nice.
Yeah.
And what?
Asking, oh, sorry. I was just saying, in chat with a good autographed book. I don't have any physical copies of the book, so it's going to be very difficult. But if I see you in person sometime and you want my autograph on a random piece of paper, I will gladly do that for you. Or if you want to print out the book and you want me to sign that, I will. I will do that.
The book that you will receive, it will be an online book. Yeah. Okay. Do we have any more questions? If not, we can wrap it up.
Do you want to say something about DAX? I'm wondering.
DAX, yeah. So DAX, for people wondering, it's like basically a cache for DynamoDB. I would say it's like a hosted Redis sort of, but it's also integrated more directly with Dynamo. Like, usually with Redis, you would need to sort of check to see if it exists in Redis. If it doesn't, you go to your source database, bring it back, save it in Redis, and then return to the client and handle that sort of thing. Whereas DAX, you can actually issue requests directly against DAX, the cache itself. And if it's there, it'll return it back to you. If it doesn't, DAX itself will go to your source DynamoDB database, run that query, pull it, save those results in DAX, and send it back to you. So it's like a more managed cache option, which is pretty nice. I would say I don't use it because most of what I do is sort of serverless type stuff, and DAX is more of like an instance-based thing that brings some of the downsides of a relational database that I talked about. I didn't quite talk about like connection model and VPC and networking that you also have to bring in with a relational database. But you need to bring that in with something like DAX, and now you have your Lambda functions and VPC. It adds a bunch of complication. So I haven't used DAX a whole lot, but if you're using containers or instances more than you're using Lambda functions and you really have a need for speed, I would say DAX is awesome for that.
So DAX is VPC based? I didn't realize that. I just know of it, I just have never used it. Yeah. Okay, thank you.
Yep. Yeah, you'll have to maintain a persistent connection to it like you would with a relational database or Redis, something like that, which allows for really fast, sub millisecond requests, which is nice. But then, you have the sort of networking issues as well.
We have a question from Isa, Alex.
Yeah. So as I see DynamoDB, it is designed for highly scalable applications with maybe thousands of requests per second. It can handle, let's say, writes. So what are the other ways of accessing it? Because I saw that API gateway is pretty expensive. I mean, if we have an architecture with API gateway plus DynamoDB, and if we have too many requests, like thousands per second, I saw that the API gateway bill can get really high quickly. So what are the options for accessing it in other ways?
Yeah, good question. So it is very frustrating that a lot of people, if they have a pretty simple architecturally serverless application that has API gateway, Lambda, DynamoDB, and CloudWatch, very often I see the bill be like 40% API gateway, 30% CloudWatch logs, 20% DynamoDB, and 10% Lambda, which I think is just completely inverted from how it should be. Like if you told me 10 years ago, this is what I would say. If you told me 10 years ago that I could have an infinitely scaling database with pay-per-use requests that's always going to have sub 10 millisecond performance. I can have an auto-scaling pay-per-use compute, and I have basically like Nginx as well. It doesn't make any sense that Nginx would be the most expensive part of that architecture, but somehow it is, which is frustrating to me. A couple things I would say, like they've made it better with the V2 of the API gateway. So it's called HTTP APIs, which is kind of hard to search. You need to Google API gateway HTTP APIs. Those are going to be cheaper. So the original API gateway was, I believe, $3.50 per million requests. This one is, I think, $1 per million requests. So pretty good amount cheaper. That helps. You can also, if you're going to have pretty consistent traffic, you can use an ALB, an application load balancer, and route that directly to your Lambda function. It's a little more sort of just like work to get it set up. And there's going to be like a sort of always on instance cost that you're not going to have with API gateway. But if you have a nice consistent amount of requests, that can save you quite a bit of money as well. So those are your options if you're using HTTP requests to Lambda functions that then end up calling DynamoDB. I would say that the people that are really using Dynamo because of its, I'd say there are two areas where like, hey, Dynamo's a really interesting fit here. And that's number one, if you have very high scalability issues. And number two, if you are using serverless applications because of some of those things we talked about before. And those don't necessarily overlap, right? I'd say a lot of people that have the very highest scaling work and are using DynamoDB because of scaling aren't necessarily using serverless as well, because if you have that much scale, that much consistent traffic, you might also have latency requirements there. Serverless might not be the best fit for you there. It sort of depends on where you are. Also, if you have that sort of traffic, you've probably been around for more than a couple of years and maybe you weren't using Lambda, you're something else. So those don't necessarily overlap, but you do see people that are using DynamoDB with serverless at very high scale as well.
Anybody else? Okay, if not, Alex, then you can have a word for the end, a wrap up, and yeah.
I can just get my last one, but yeah, thanks for having me. It was great. Anyway, you can find me, on Twitter, blog, all that sort of stuff. Yeah, but feel free to ask questions about anything. I'm pretty available on Twitter, on email and that stuff. Great questions here, but also if you have additional ones, feel free to reach out. Again, if you're interested in the book, go sign up, dynamodbbook.com, get a free review, all that sort of stuff. But otherwise, thanks for having me.
Okay, everybody, thanks for joining. Please check out the messages at the AWS user group, Kosovo. If you're not part of the group, please become one. And we will have these events often during the year, and hopefully we will have also live events, not only online. And this will be recorded. This was recorded, and then it will be edited as a video and put up online. This presentation of the AWS user group meetup. And also something else, if you, all the participants, if you know somebody who's a beginner software engineer and wants to join our program, we have a new training program, a 6-month training program, fully funded from Polymath Labs. And like in 2 weeks, the deadline is in 2 weeks, so just follow us on Facebook at Polymath. Thanks a lot, Alex. Yes. Thanks very much. You can follow Alex at, you can read actually his posts, his blog at alexdebris.com.
Yeah, thank you, Alex. I want to say a special thank you in the name of the community for being able and for accepting the invitation to do this talk. I'm sure we'll be meeting you again along the way when trying to write some code or build the database. So as for our community, all of the participants will be added on our Slack channel, and we will be sending to the winners the code to download the books Alex has given to our community. So if anyone has any questions, we can discuss them in our community channels, or you can DM us. And yeah, see you on other meetups.
thank you to all. Don't forget, this video will be published on YouTube, so follow our page on Facebook and you will get the information there, but also we will put up the information at the AWS user group Kosovo. Thanks, Alex, again. Next time we see you in Kosovo.
Yeah, perfect. Let's do it.
Don't say yes if you don't. Okay. No, we'll invite you actually as soon as this pandemic is over, so we will have something with you. So thanks a lot for everybody for joining in. See you at the next meetup.